All right. Thank you for coming to the session. My name is James Taylor, and I'm going to talk to you about preventing AI failure. There's a critical role for business analysts to play in preventing AI failure, and I'm hoping to articulate what that is, how you can do it, why you should do it. So first, a question for you all. How many of you are business analysts? Okay, that's good, because the whole presentation relies on the fact that most of the audience are business analysts, and so if you hadn't been, I'd had to sing or something. So a little bit about me. I've been doing this a long time, much longer than I'm really comfortable admitting, but a very long time. I've written a number of books on decision modeling, on decision management, on digital decisioning, on machine learning and AI, and what I want to share is what we've learned in that process and how business analysts like you can be the difference between success and failure when it comes to AI. So let's talk a little bit about AI. There's tremendous excitement and interest in AI, artificial intelligence. An HBR article predicted $13 trillion being added to the global economy in the next decade. A study done this year said that 97% of executives think their company is investing in AI. Other studies by people like MIT Sloan and Stanford have found that 75% of business executives think that AI will enable them to create a new business or move their business into a new area. 85% think that it will enable them to build or sustain a competitive advantage. In Tom Davenport's new book, he found in another survey that 76% of executives think it will substantially transform their company. These are big, impressive numbers, even for overhyped technology, of which there is plenty. As a consequence of these kinds of numbers, companies like yours are spending an enormous amount of money on machine learning and AI. And the bad news is they are mostly wasting it. It is not getting done. You look at some of the surveys for this. Gartner, CIOs, this year, 86% have initiated an AI project, but only 4% have AI deployed. And these are CIOs, so you know that means there's one AI system somewhere in the company that's deployed, not that the whole company is running AI. There's a gap between ambition and execution, despite those huge numbers. Other surveys have found that 20% think they've got AI running in some process or system somewhere, and only 5% in a Stanford Business School study found that they had it widely deployed. Now you'll notice that the ones at the bottom, that's McKinsey and Stanford, so those are business people. They think it's 20% in some and 5% extensive. The CIOs think it's 4% at all. So, which one do you think is probably right about what's actually deployed? If it's 4%, we're lucky. We are not getting AI deployed. What we find and what you see in the research is that most firms are struggling to get beyond very ad hoc, limited scope pilots. They are perhaps embedding a little bit of AI in a process in a pilot or experimental way, and that's it. Well, this is obviously not really acceptable, right? We're spending a lot of money. We are wasting an enormous amount of it, and we have to do better. And so I was trying to think, well, what could you do to begin to sort of help people do better? Well, one of the things you could do is you could define what valuable AI would be. What would a valuable AI algorithm look like? How would we define a valuable AI? Well, we might say that it's an algorithm of any type that has caused the organization that paid for its development to change its decision-making in a way that has added business value to that organization. That's a pretty simple definition, but it's got a couple of key components. First of all, it talks about change and it talks about decision-making. We all know that if we do the same thing the same way, we will not get a different result. So if we want to get a positive outcome, value from our AI, we are going to have to change something. And when you talk about data and analytics and machine learning and AI, what do people say they want? They want to make better decisions, data-driven decisions. I want to use my data to improve my decision-making. So if you don't change your decision-making, it's unlikely that you have improved it. So you have to change your decision making using the AI. The second interesting part about the definition is this one, because it has two interesting characteristics, that second part. First of all, it's written in the past tense. I'm not interested in projections of value. When rolled out, when deployed at scale, should, is expected to. How many of those words have you seen in case studies of AI? Well, I don't know about you, but that's all I ever see in case studies of AI, to be honest. The second thing is it's business value. I want to know that there is some business metric that your executive team cares about that you can say, well, 2 quarters ago before the AI it was this, 1 quarter ago after AI it was this. That's the improvement. And in that same period, our competitors did not manage to improve that metric, because that would prove that the AI was delivering business value. Now, I'm going to ask you to do a show of hands here, but don't put your hands up yet, because there are some rules. Okay, and this is a conference where rules are important. So if you have in your company an AI algorithm that is actually deployed and in use, where you feel that someone in the company could describe positive results in business terms, not accuracy or lift or precision, but actual like business metrics like fraud or customer satisfaction or referral rates, and that you could do that by referring to historical data and not a projection, and you don't work for a tech startup, and we're not talking here about RPA, chatbots, optical character recognition, natural language recognition, or image recognition, because although those can all use AI, they're not using AI to improve decision making. So with those criteria, how many of you believe that you have a valuable AI in your company? So there are some optimists present. That's good. Okay, that's good. I'd love to talk to you about it, because I'm desperate for case studies of AI that's actually deployed and really in use and really generating business value, because normally when I apply my criteria, I find that there's a problem. So I'd love to chat with you in the break, but regardless, as you can see, not a very large number, despite the amount of money being spent. Now this at one level seems a little odd. How hard can it be to build valuable AI? It seems like the process is relatively simple, right? We want to build an AI, so we're going to build an algorithm that addresses a problem or an opportunity in our business operations. And we are going to do that in a way that operations can use the algorithm, because obviously if they can't use it, they won't adopt it, and if they don't adopt it, it won't have any value. They have to believe it. It has to be explainable enough or believable enough or visible enough that they can trust this AI is going to be right, and then embed it in the systems and processes that they actually use to run operations. This seems like a relatively simple list of criteria. Do this, then do this, then do this, then do this, then do this. Well, it turns out that it's not. It's actually remarkably hard to build valuable AI. And there are 2 broad buckets of problems. The first is that there are a bucket of AI algorithms, machine learning algorithms, predictive analytic models, that are not actionable. That is to say, the problem they solve is not the problem operations actually has, or it's too hard to use it, or it's too expensive to use. There's something about it that means it's not, practically speaking, operationable. Give you an example. I was talking to someone and he was convinced that if they built an algorithm to predict maintenance problems, they could help airlines cut their maintenance bill. And I'm like, why do you think airlines do the maintenance they do? Well, because they think parts are going to wear out. No, they do the maintenance they do because the regulators tell them they must, and the manufacturers tell them when to replace things. And there are whole books of rules from the manufacturers saying if you replace this, and these other parts are older than that, they have to be replaced too. And all of that is provided to them, and they basically follow those guidelines, and that's what they do. So you could predict that they should do something different, and it won't have any impact. It's not actionable, because they can't afford not to do what the regulators tell them, and they can't afford not to do what the manufacturers tell them. So your algorithm could tell them something, and it would be utterly irrelevant. They're not going to act on it. Now, some AI teams are better than that. They figure out an algorithm that ought to work, but it isn't action. No one takes action about it. It's not integrated, it's not believed, or it just can't be used. So we did a project a long time ago now with a company that had developed a model, a machine learning model, to predict risk in healthcare fraud. So these are healthcare claims. How likely is this provider to be a rip-off merchant? How likely is this claim from this provider to be false? And the analytics team, looking at the data, said, hey, we can divide these up into risk quintiles. The highest risk quintile, top fifth, second, third, fourth, fifth. And we can tell people that. And unlike many teams, they realized that they had to deploy it. So they built a system, and they built a web page that ran on the intranet, and you could type the name of a healthcare provider in, and it would tell you which risk quintile they were in. And no one used it. And they could not figure out why no one used it. And the reason no one used it was that was not how the claims people thought about the problem. They divided people up into people who smelt bad and people who didn't smell bad. And they literally couldn't figure out which one of the 5 quintiles counted as smells bad and which ones counted as doesn't smell bad. And so they ignored it, because the way the analytics team, the machine learning team, thought about the problem could not be actioned in the context of the actual business process that was really running. So when you look across the projects that have these problems, that are not actionable because they solve the wrong problem, or they solve the problem in a way that's never going to be actionable, and those that are theoretically actionable but aren't actually put into production, you discover that there are 2 critical things you have to do. Critical success factors, key concerns that you have to recognize right up front. The first is it really matters what decisions you are trying to apply the analytics to. There is a tendency to say, I'm going to build an analytic, and then once I've got an analytic, once I've got an AI algorithm, once I've got machine learning done, then I'm going to try and figure out what I can do with it. This doesn't work. You have to begin by saying, well, what decision am I trying to improve, and then go look at the analytics. The second thing is that machine learning, AI, these more modern algorithms cannot stand alone, that they are not enough to solve the problem. You have to mix them with other kinds of technologies, and that one of the reasons AI programs go so poorly is that the essence of an AI program is to be technology-led. AI is a technology. If you have an AI program in your company, it's a technology program. Well, you're all business analysts. You will know that projects succeed much better if they are business-led than they do if they are technology-led, and so we really need a way to rethink this. So what you have to do, and what we'll walk through in the rest of the presentation, is how do you establish a way of thinking about AI that is much more focused on the business decisions you are trying to improve, more decision-centric way of thinking about it. And secondly, what other technologies do you need to mix and match with your machine learning and your AI? And in particular, what's the role of business rules in doing all of this? So let's talk about these things one at a time. So this first point, decisions matter. If you think about a decision, a place where you have to make a choice, there are several things you could do. Which one are you going to do? That's what drives your metrics. It's what drives success or failure in your business. If you make consistently good decisions, your results improve. And if you make consistently poor decisions, your results go down. And it turns out that knowing what decision you are trying to improve really matters. Now, we have a little phrase we use that we mean, you know, with love, as they say. We talk about our client base being big, boring companies. Many of you, I suspect, work for a company that meets that description. It's big, it's boring. And that being big and boring is actually part of its value proposition, right? It's big, it's boring, it's stable, it's reliable, it will be here next year, it'll be here next decade. If you buy a life insurance policy for us now, in 30 years when you retire, we will still be here to pay it for you. Those kinds of companies make a lot of decisions, and they have been making them a long time, and you have to somehow figure out what the decision is that you're going to improve. And when you start looking at these decisions, the particular kind of decisions that matter the most are operational ones. Decisions about a single customer, a single transaction. Should we pay this claim? How much should we charge this customer for this policy? How do we escalate this complaint? Which supplier should we use for this order? Because those decisions happen over and over and over again. And so if you're trying to build an algorithm, you're going to invest in building an algorithm, you're going to need to get a return on that investment. Well, how do you get a return? Well, you get a return by using it over and over and over again. So if you can focus on these high-volume operational decisions, well, you have much more opportunity to get a return from your decision-making, investment from your algorithms. And it turns out that particularly digital decisions, automated decision making. There's a lot of talk at the moment about augmenting people with AI and presenting AI results to human beings and trying to help people make better decisions. And hopefully this will wear off soon, because frankly it doesn't work. Because the reality is algorithms are pieces of code. They need to be wrapped with other pieces of code, with logic, with other things that turn them into an automated decision. That doesn't mean you have to automate 100% of the decision 100% of the time. But if you're going to use AI effectively, you need to embed it much more deeply in your systems than people seem to think. We had a conversation with a client in Asia, and they had been partnering with an insurtech company that did claims handling, and they were going to build an AI that you sent paper claims in one end, and the AI spat out, pay this one, don't pay that one at the other end. So it did everything from scanning, optical character recognition, translation, mapping to ICD-10 codes, identifying fraud, is the policy enforced, everything else. Millions of dollars, several years of work. They had, by the time we met them, processed exactly one claim, because that is just too lumpy. And the problem was that big lumpy AI, well, in order to verify it, you had to basically make the whole decision again, right? So it was not very helpful. So you have to think about how you were going to embed these AI algorithms into automated decision-making to be effective. Now, interestingly enough, Tom Davenport's new book had a great way of phrasing this. He said, if you look around, there are relatively few examples of radical transformation with AI succeeding, and many examples of what he called low-hanging fruit being successfully picked. Moonshots with AI have a very poor track record. We're going to change the business, create a new business out of our data. We're going to radically transform the entire company. No, really, you're not. Almost certainly you are not, in fact, going to do that. You are just going to spend a lot of money on AI. If you really want to transform your business, you have to do it one decision at a time, one very low-level transactional decision at a time. And you have to focus those analytics down at the operational level. That's where your data is, and that's where the repetition that will let you get value from that AI is going to be found. So that's the first thing we've noticed, that the AI projects we see that have any tracking to success are very, very specifically focused on a very narrow definition of success that is defined by a high volume, transactional, operational decision. The second thing is this whole issue of, does my AI, does my machine learning stand alone? Do I treat this as a separate activity? And if you've ever worked with data scientists, machine learning algorithm folks, they have a phrase they use a lot. They like to say, let the data speak. We're going to go look at the data, and we're going to see what the data tells us about how we should run the business. And this is not a bad thing. I'm not arguing for a moment that you shouldn't let your data speak. But you have to let your experts speak also. Because the reality is, you've been making all these decisions a long time, and your company is still in business. That probably means there are people in your company right now who have a pretty good idea how to make this decision. They know how it's made, they know how it should be made, they know what kind of things can go wrong. They have domain expertise in how that decision is made, and ignoring them, just listening to the data, is not going to work. We had a great example of this, the example I gave just now of the quintiles. When I asked them, well, what did the claims adjusters say? And they looked at each other, and I'm like, one of you did go talk to the claims adjusters, right? Well, no one had talked to the claims adjusters. They had just taken the claims data and analyzed the claims data. They have all this lovely data. Why would they need to go talk to someone? I feel like reusing that old joke about programmers. You know that old joke, you can tell an extrovert programmer because he's looking at your shoes. Well, now the same is true of data scientists. They're not, by and large, very chatty people. They don't go talk to people naturally. They would rather just look at the data. So if you want to also get people to speak, you have to actively engage in that process. It's also true, and the other reason you have to speak to experts is that it is not automatic that an algorithm is going to be the right solution, that an AI or machine learning algorithm is not always the best way to make a decision. Take that example of claims. If I'm processing an insurance claim, machine learning might be a great way to tell that there's potential fraud, that you haven't disclosed something to me. But if I want to know if your policy is in force, Why would I train an AI to learn that your policy is enforced when I can write a set of rules that tell me your policy is enforced based on the date and kind of policy and whether you paid and everything else? An algorithm is not always the best solution. So now we take these two threads and say, well, what's preventing projects from doing this? If I have to focus on decisions and understand decision making, and I can't just build an algorithm, I've also got to talk to the experts in my business and find out what they need, what they know, and how they do things and how things work. What challenges does this create? Well, what it does is mean there are 4 groups you have to talk to. You have to talk to the business, because they understand what the motivation is of all these things, how you track success, where you might be going next, what the big industry trends might be. You have operations people who know how things are done right now, who actually process these transactions, look at these transactions, run through these checklists. You have IT people who know what the system does, where the data is, how good the data is, how timely the data is, which systems get used, which fields get filled in incorrectly. They have a sense for what that looks like. And then you have the data scientists and analytics team, who are the ones who hopefully can tell you what your data is trying to say to you. And the challenge is that to succeed, I have to get all these 4 groups to work together. I have to find a way to get all of them on the same bus. Well, they're a pretty diverse group of people, and often they don't get on well. Business and IT have a long history of a little bit of tension, but IT and data scientists don't get on much better. And the analytics team really hate the idea that they might have to talk to a business person, because they're really data people. So you have challenges that you have to resolve in order to make these projects succeed. And in that context, there is good news and there is bad news. So good news first. The good news. What is the good news? Well, the good news is this is your skill set. This is not a different problem for business analysts. You're used to the idea that you've got multiple groups of stakeholders with different perspectives who all have to be brought to a shared understanding of what the problem is. That's the good news. You can do this, right? This is why business analysts have to be involved in AI projects if they are going to succeed. All right, they were thinking, good, that means I've got a job still because I'm going to be helping people build the AI. What's the bad news? The bad news is that our experience is that the way you do requirements won't work for decision making and won't work for AI. You are, to coin a phrase, trying to hammer a screw, right? The world has changed. How AI works, how machine learning works, how decision making works is sufficiently different that you can't just mindlessly or blindly apply the techniques you've used before. Requirements documents, harvesting rules, building a business process, all of these things have value for certain kinds of systems. But when it comes to systems you're going to embed machine learning and AI in, they don't cut it. You have to find a new way to articulate your requirements. And so I have a call to action for you based on that, based on this experience, based on what we observe. I want you to model these decisions. I want you to think about decisions, I want you to identify decisions, and I want you to build models of decisions, because that is what will let you identify how you can use machine learning to improve your business. Now, show of hands, besides Don, who I know, who else has built a decision model? Anybody? Okay, we got a few people. That's good, all right. So, most of you have never seen a decision model, I suspect. So this is a decision model. This is an example from a simplified example of the claims story I've been telling. So what does a decision model do? Well, it enables you to model a decision. Perhaps unsurprisingly, if you were to analyze the text, that would be what you would have guessed. It allows you to represent graphically the structure of a decision very precisely. So you can take the decision you are trying to make. In this case, how do we handle this claim? Do we pay it, reject it, review it, or investigate it? There are only 4 things we can do with a claim. We have to pick one of those 4 every time we get a claim. So how do we pick what straight-through processing approach we're going to use for this claim? And what we're going to do first is say, well, what specific question are we trying to answer? We're trying to say, how should we handle this particular claim? What is the straight-through processing status appropriate to this claim at this time? And then we have 4 allowed answers: pay, don't pay, review, investigate. Great. Now I know what decision I'm trying to make. So I can start to think about the data that I need to make this decision. I might have data about claims and data about policies and data about policy holders, data about claimants. I've got these kinds of what the modeling notation calls input data. And this, by the way, is using a standard notation called the Decision Model and Notation Standard, DMN. But how do I connect this data that's going to help me make this decision with the decision I'm trying to make? Well, I write other decisions. Every rectangle on that diagram is a decision. And so what I've said here is that, well, in order to decide how I'm going to handle this claim, I have to decide 4 things first. I have to decide if the claim is the kind of claim we're willing to pay automatically. Is it eligible for straight-through processing? I have to decide if I have any fraud or validity concerns about the claim. I have to decide if there's potential wastage in the claim that I would like to review. And I have to decide how complex the claim is as well. Only once I've decided those 4 things can I decide how I'm going to handle the claim. Well, how do I decide those 4 things? Well, you can see I can break down each part of the problem into further parts and further parts, sub-decisions, sub-sub-decisions, sub-sub-sub-sub-sub-sub-sub-decisions, however many I need in order to make all this work. And then I can annotate this diagram with the knowledge that tells me how. Where am I going to get the rules for this? What kind of analytic insight do I need? What regulations constrain how we do this? Who knows? Whose expertise is relevant? And I can document all of those sources of knowledge on the same diagram using this little document shape. That's it. Really, that's a DMN model. As you can see, it's not a very complicated modeling notation. It's got 3 shapes and 2 lines. It's relatively easy to learn to read them. And we've taught lots of people how to build these models, and lots of business users who have become able to articulate their problem in terms of a decision model. Why is this useful? Well, once you have a decision model, it turns out that that is what you need to get everybody on the bus. Because the business people can see that this decision is constrained by the regulations they know they're constrained by. They can see which metrics it helps them hit. They can see how this decision structure relates to the way they make decisions today. The operations people can walk through the decision model and say, well, here's an example claim. How would we have made each of these decisions for this claim? Does that make sense? Does it hang together? Does it look like what we actually do? The IT guys are used to models. They're used to UML and data models and process models, so they understand it. And the analytics team can say, oh, so if we could predict this, or if we could predict that, you could use it in this decision. Now I see the decision context for the analytics, the machine learning that I'm trying to build. That'll make it a lot easier to build one that will be actionable and be useful. So decision models are the tool that gets everybody on the bus. Now, so let's pull those things together into a sort of action plan. We've got to focus on decisions if we're going to succeed with AI, because we need to know what we're going to do with the AI. We need to make sure we can mix and match AI and machine learning technology with the other kinds of technologies that are relevant. And we need somehow to use decision models. So what does that look like as a plan? Well, step 1, as I like to misquote the late Stephen Covey, you have to begin with the decision in mind. You have to focus explicitly on the decision itself. Not on the UI, not on the process, not on the data. Those are valid things to concentrate when you're trying to do other parts of the system. But when you're trying to think about AI, you have to think about the decision. And you have to know what better means. Everyone says, oh, I want to make my decisions better. Okay, what does better mean? Can you prove it? If I invest $1 million in this new system and I improve the quality of that decision, in 3 months' time, will you be able to see how I improve the decision? Will it show up in your metrics, in your data, in your dashboards? Because if the answer is no, we're not going to get very far. The second step, we have to let the experts speak, not just the data, so that we capture how business and operations think about this problem. And the third step then is to use these things and a decision model to frame the AI that we need. So each of these, I'm going to give you a couple of tips. So this first step, begin with the decision in mind. So ask yourself on a project that you're working on that wants to use AI or wants to use machine learning, say, well, what are our business measures? How do we measure? What are we trying to influence? Why are we spending money on AI? So let's say your business exec says, well, because we want to improve customer satisfaction. Great, okay, so that's the metric. what decisions do we make that impact that metric? Customer satisfaction. Well, how we price the product affects how happy customers are. How we handle renewals affects how happy customers are. And whether we pay their claims promptly affects it. Okay, so 3 candidate decisions that we might get better at and hope that that would improve customer satisfaction. Great. Which one do you want to improve? Because you can't just like wave your hands and hope that you'll generally improve decision making in some vague way. You have to be precise. Well, who's made a claim recently of their insurance company? Really focuses you on whether you have a good insurance company or not, right? Because it's like, you don't want to know the status, you don't want to know anything, you just want them to pay the claim, right? So it's like, it's a very focusing thing. Do a good job of claims, people like you, they refer you positively. Do a crappy job of claims, they renew with somebody else. So we're going to pick claims. So pick claims handling decision, that one we were looking at. That decision, if we get better at that decision, customer satisfaction will improve. That'd be great. That's what we want to use machine learning for. Okay, one last question. What does improve mean? Well, obviously, customers really just want us to pay the claim, so the number of claims we pay straight through processing rate. Great. So why don't you just pay all the claims? Well, then there'd be lots of fraud and waste. So what you mean is you want to increase the rate of straight-through processing without allowing more fraud or more waste. Yes, that would be a better decision. Well, now you know what your project is for. It is about the decision and not about AI. And so by definition, it has become a business project and not a technical one. Didn't take long, did it? So now we're talking about a business problem with a business outcome and business value long before we've talked about the AI technology we might be applying to get there. The second step is to go talk to all these experts. This is where you come in. Obviously, you can ask that first set of questions. Make sure that everyone's clear what the business purpose of this project is. But trust me, the data scientists are no better at talking to your business partners than the programmers are. Right? Anyone, I'm sure some of you have programmers who are really good, really engaging, extroverted kind of people who just love running facilitated sessions, right? And most of you think that's like a unicorn, right? They've never met one. Well, data scientists are basically the same. In fact, we even call them unicorns, right? And they are just as good at talking to business users as you would expect. So you have to be able to get a wide range of people. The people who run the business, the people who get to say, we do this because of this regulation, because of this policy, because of this past strategic decision. I talk to people in operations, whether they're people who talk to customers on the phone, in the call center, people who meet with customers, the people who have the policy manuals, who update those manuals, people who work in the branches, people who work in the factory, the people who actually make the decision now. Because trust me, if it's an important decision, someone is making it right now in your company. And now again. And probably again by now, right? So it keeps happening, so someone must know. So find out who those people are and go talk to them. Capture their expertise, their knowledge of how this decision is made. Talk to actual business people, actual operations people. This is often a bit of a sticking point when we do consulting projects, right? We'll come in and we'll say, well, we want to do this workshop 2 or 3 days, and we need actual decision makers. And they're like, well, send us the agenda so they can see which part of the meeting they're going to come to. No. They're going to come to the whole meeting. Like 3 days? Yes. Well, they won't do that. Well, then, okay. When they're ready to do it, we'll start the project. And they're like, well, it'll take them weeks to schedule. Yeah, we know. Get them to schedule far enough out that they can cancel all their meetings and cancel their phone calls and actually spend time telling us how this decision gets made. Because if we don't know how this decision gets made, there's no point in spending money on anything else. It simply will not work. Okay, so get these people, get them engaged. Don't be fobbed off with, read this requirements document we wrote. Oh, we'll send you an Excel spreadsheet with all our thoughts and rules and comments in. No, you have to interact with them. It has to be an interactive exercise to build a decision model with them. And we call this decisions first design thinking. So it's applying the principles of design thinking, but to the decision itself. Know where you are, get it, ideate new ways to do it, prototype it, go through that exercise, but using the decision and the decision model as a framework for doing that. So now we have a business problem we're going to focus on this business decision because of these reasons. This is what better means. And we're starting to build a model that explains how we make that decision today. So then we can get to step 3. And step 3 is the one that's going to kick off our exercise with machine learning and AI. We're going to take this decision model, which is still the decision we're trying to improve. And the first thing we're going to do as business analysts is say, you know what? There's a whole bunch of decisions in this model that we know how to do. They're based on expertise. They're based on regulations. They're based on policy. We're not going to change them because the machine learning model tells us we might want to, and we're not going to ignore them. And we might have to prove that we did them because they're regulations and we're required to demonstrate compliance. Well, you guys did a great conference for this because it's all about rules. It's about making sure you know what rules make each of those decisions in that model. So you can look at each of these decisions and say, all those orange decisions, hopefully they show up as orange, they do. All those orange decisions, we can write rules for those. One decision at a time, one piece at a time. What are the rules that tell us how to make that decision? Well, now you have a framework for making this decision. So now you can start to say, well, what else can I do? Well, you might have data that tells you how to write some of these rules. So we had an example here. These guys had a report they did every year that said, here are all the treatments that we get multiple claims for, the conditions that we get multiple claims for, and here's the average length of stay in hospital for them by region. And they had the mean and standard deviation for all their common treatments. And we said, that's great. It's a very interesting report. What do you do with it every year? Send it to everyone. What do they do? Read it? Does it make any difference? No. But it's good analysis. And we said, yeah, it is good analysis. I tell you what, why don't we use it? Why don't we take that decision in the wastage section that says a claim is potentially wasteful if you stay in hospital rather longer than we expect. Well, right now, your claims adjusters do this by, a sniff test. Yeah, it looks a little long to me. But we have all this great data. So why don't we write a set of rules that say, if your length of stay is more than 1 but less than 2 standard deviations above the mean for the treatment you are claiming for, well then, that's a little bit wasteful. And if it's more than 2 standard deviations, then we definitely want to review it. It's wasteful. So now that's still rules-based decision-making, but these are not rules that you harvested from someone's expertise or from a document. This was done by data analysis. But the rules are a good representation of it, and it's clear where they fit in this decision because there's a decision model. But then you get to the really interesting stuff where you need to get machine learning and the AI and data science teams involved because there's a game we play, and we call it the if-only game. If only we knew blank, we would decide differently. And in claims, for medical claims, pressing the wrong button. If only we knew who had an undisclosed medical condition, we would decide differently. Because if we knew you had an undisclosed medical condition that you didn't disclose when you bought the policy, we would never auto-pay your claims. We would always review them because we would want to make sure that it wasn't relevant. But we don't know, obviously, who hasn't disclosed a condition because you didn't disclose it. That's kind of the point. So how do we deal with this? Well, the machine learning team might go, you know what? We might be able to predict how likely it is that a given person has an undisclosed medical condition. We can use the kind of claim they're making, how much they're claiming for, what kind of condition they have, where they live, how recently they bought the policy. A bunch of those things are probably pretty predictive of whether or not you haven't disclosed something. So great. Well, now you can ask all sorts of interesting follow-up questions. How accurate would it have to be before you were willing to refer the claim for fraud investigation or for review? How accurate would it have to be? How certain would we have to be that they didn't have one before you were willing to auto-pay? How timely would it have to be? How current is the data that we can get access to? How long does it typically take you to find out that someone has ripped you off if you don't detect it? We're going to ask those kind of questions so that the analytic, the machine learning algorithm that we build is actionable in the context of this decision. And you get some very interesting results sometimes because you get answers that are unexpected. We did a disability claims one, and one of the models in it was, how likely is it that we want to know if the doctor's medical report says you have the condition that you're claiming for? Okay. And we asked the business owner, in the context of this decision model, how accurate would this have to be? And she said, better than 50-50. And the analytics team, the data science team, fell off their collective chairs And in fact, they asked her to say it again and wanted to record her saying it because they didn't really believe her. Because from their mind, if a model's not 95% accurate, what good is it, right? And they're all worried about the data quality and about this and that because they think they need a 95% accurate model. And she's like, well, in the context of this decision, we've already decided it isn't mental health related. We've already decided you're not someone we have prior history with. We've already decided that your agent is not on our blacklist. So really at this point, we just need to, is it probably true that your doctor thinks you have the condition that you have? That's enough to move it through the process without review. Didn't pay it, but it moved it forward. And so they saved huge amounts of time and money on that machine learning model because that was a much, much simpler problem to solve. It was much easier to build a valuable AI because they knew exactly what decision it was going to improve, what improve meant, and where the machine learning model fit. So a closing thought before I take some questions. You're business analysts, and only you, and I really mean this quite genuinely, only you can prevent AI failures in your company. Right? Your company will spend money on AI and machine learning, I guarantee it. And it will waste most of that money, because everybody is. Not everybody, we had like 2 or 3 people who haven't wasted all the money, but everybody else has wasted all the money, right? And there are 3 things you have to do it. You have to make sure that the AI projects in your company are clearly tied to a very specific business decision that you wish to improve and for which you can define the word improve. Begin with the decision in mind. The second thing is that you have to make sure that this project doesn't just go look at the data. That is necessary to build a machine learning model. It is not sufficient. You have to begin by talking to the experts, understand how you make the decision today, what that looks like, how they think it must be made, should be made, could be made, and then and only then try and improve it with machine learning. And you use decision modeling as a way to capture this understanding of the decision in a way that is visual, that is shareable, that is precise, and that frames the AI problems that you are trying to solve so that you can succeed. That's how you get valuable AI in your company. It is your job. So if your company ends up, if I read about one of your companies in the press saying they've wasted all this money on machine learning, I'm going to blame you. Okay, it will be your fault. No, seriously, it won't be your fault. There are lots of other reasons it can go wrong. But it is certainly true that without your help, it cannot possibly succeed. And with that, I'll take questions. Now we have a few microphones, and I even have a conscripted volunteer here to run the microphone for you. So if you have a question, put your hand up. We'll get a microphone for you. There we go.
Thank you. You mentioned that we should use decision models to maintain a repository of decision, and that's going to be the starting point for applying the AI. But so that's our job as a business analyst. But what does it take to introduce this model and DMN to the AI experts that they are not used to this to apply this?
Yeah, so how do you get the AI team, the machine learning team, the data scientists to adopt this? Well, there's generally, in our experience, 2 broad buckets of data scientists in this regard. There are those that are following a methodology of some kind. A lot of people use CRISP-DM, or they use one of the variants of CRISP-DM. They like to say they have a methodology. And if they say they have a methodology, the first step in that methodology will be to get a business problem statement or a business understanding. And as business analysts, you can say, the best way to get a shared understanding would be to build one of these models. So you're saying, you already have a step in your process where you're meant to get business understanding. I have a better way to get what that understanding is. Let's go build a decision model. So they're typically not too hard to convince because they're like, oh, okay, that would work, right? Then there are the kind that don't have a methodology, right? They just like to write Python code or PySpark and argue about TensorFlow and this, that, and the other. Generally, you have to go further up the food chain. You're better off trying to influence the business people who want to use AI, who want to use machine learning. Because those kind of guys, they really just want to go look at the data and write code and get started, right? But it is interesting when you look at surveys of data scientists, they are highly motivated by how complex their problems are and by whether or not they can solve them. Do they actually get stuff done, right? And so they're not motivated by pay or other things generally. They're problem complexity and success with problems. And so you can sometimes say, look, there's a real risk, guys, that you could build a machine learning model and those people over there, they won't be able to consume it. So you'll build something really clever, won't have any impact. Let me help you figure out what they do so that we can understand how to take what you find out and plug it into what they do so that you can get a success. So to some extent, you're telling them that the problem is that the business users are stupid, right? And that you can help them resolve that problem, right? And meanwhile, you're telling the business people that on no account should they allow the machine learning people out unsupervised, right? So you're like trying to play both sides against the middle here, right? And say, we can play a thing. It's generally not too hard with the people who have a methodology. It can be really hard with the other ones, right? Because they're just not doing it. And they're often in their own little group or their own building, or you've opened a special office in Silicon Valley where they all live, right? And so all of those things make it hard. So let's like IT from the 70s, where the IT department was in another city, right? It's a bit like that still. Great question, though. Anybody else? And if you're interested for a question, I have a copy of a book on decision modeling that you're welcome to have a copy of for asking questions. But you already have one. Okay, well, you can take one for a friend if you want. But anyway, but anybody else who asks a question, I'll happily give one to. So, all right, we got a question there.
Does the effectiveness of these projects kind of rely on the existence of process models? So you mentioned low-hanging fruit as being easy targets, but many of us are many steps before that in that we don't have an inventory, we don't have agreement on what current state is, but they want to throw AI at it because it'll help with that too. And how do we bridge that gap?
Yes. It is clearly easier to build a decision model and implement AI and push AI into a well-defined business process where there's a clear step in the process where you need the decision made. Yes, for sure. However, we have found that you can do it in other places. Often, there is a place in the, if you like, where people say, I have to decide something, and they're pulling up various data on various forms and everything else, and just modeling that decision and saying, well, you keep doing this bit of the decision over and over again, but we could automate that bit. Instead of you doing this analysis, we could use a machine learning model to do that bit. And so you can take a place, a UI, or a moment in time, a dashboard, or a spreadsheet that they look at, and you can sometimes automate, not the whole decision, but some of the mechanics of supporting it can be effectively done, even if the system is still pretty goofy. The other thing you find is, are you working with RPA, robotic process automation at all? Anybody else using RPA? So RPA is a tool basically to pave the cow path, right? I've got this horrible cow path, I would like to pave it. And that's very effective as long as none of the steps in your cow path were decisions, right? So when using RPA, you have to just make sure you don't automate the bits of a decision when you're using RPA. In those circumstances, you want to separate that out and treat it separately. But back to your question. You can typically identify the decisions people make even if they don't have a good process context for it. But it's certainly easier in places where you have a good process. If you don't have a process design, the odds that you're dealing with operational transaction things are also lower, right? Because you tend to be managing things more manually. It depends on the specifics. You'd have to give me some examples and I'd happily try and help you, but I can't think of a quick and dirty way of doing it in general. So, but you're welcome to a copy of the book. One more question time. All right.
Yes, do you have an average time of how long it generally takes to create the model?
So we have a very repeatable project we tend to do with clients. So I'll use that as an example. So we do a 12-week project. The decision modeling piece takes typically the first 3 to 4 weeks to get most of it done. We generally begin with a 3-day workshop during which the people who really know, so like an actual claims adjuster, the actual manager of claims, the chief marketing officer's direct reports, have to spend all morning with us. And then we typically work in the afternoon to sort of clean up the whiteboards and model it a little bit. And then the next morning they come back and we do more. And at the end of 3 days, we typically have the whole structure done. So 100 plus sub-decisions often modeled out, but we haven't defined any of the details. Then it's 3 or 4 weeks to get all the rules documented for that model. 3 or 4 weeks, that's about right? Yeah, and then you start, then it depends, are you going to implement them in automation or not? Are you just capturing them so you know what they are? Are you going to automate them? And so on. And then you can start the rest of that project. But generally, in a few weeks, you can get a pretty robust model built and a pretty good sense of what the rules are and how it works and everything else. Now, building the machine learning models will take longer, but you at least know what the problem is. That's one of the nice things about decision modeling. It's really quick, which has been a great benefit. All right, I am out of time. My little red light is flashing. I'll be here the rest of today. I'll be around. Happy to take questions. And those of you who ask questions, you want a copy of the book, feel free to come get one. Thank you all.